Hello and welcome to Well Control for Drilling, Intervention and Workover. Hereafter, we'll examine the case of tripping R4 on dry pipe and the effect on bottom pressure. Let's get straight into it. Here is your schematic of the well being drilled. You have a drill string with certain length, 1,000 feet of dry pipe has pulled out of hole. All right, the information given here is drill pipe capacity, casing capacity, mud weight, the steel displacement of the drill pipe, all right, and the length of dry pipe that has been pulled out for. For the workover guide, when you pull out for tubing, replace the drill pipe with the tubing information, okay? So the question is how much bottom pressure has been dropped. So first, let's get to the question why the bottom pressure dropped. When we pull out the full string, dry, you pull out steel. Because steel is out, so the mud will drop to take place of the volume of steel that has been out of form. That's straightforward. So now, because the mud drops in the annulus, it causes the bottom pressure to drop. Simple, right? Now come back to the question to calculate how much the bottom pressure has dropped. Now we work out the volume of the steel that has been pulled out from. We take the length times the steel displacement. So 1,000 times 0.0076, you got 7.6 barrels volume of steel that has been pulled out from. Now you work out the capacity per barrel per foot of the mud left in hole between the casing versus the tubing or the drill piping hole. So you take the casing capacity, deduct the steel displacement of the drill pipe or the tubing. So in this case, you take 0.1522, deduct 0.0076, you get 0.1446 barrel per foot. Now you take that 7.6 barrel per, which is the steel volume outflow, divided by the barrel per foot mud capacity, right? You get the height, which is 52 feet. That's the height of the mud has dropped in the annulus. All right. Now you have the height, you have the mud weight. You use this constant 0.052, multiply them all together, you get 30 psi. That's the bottom hole pressure reduction. So for 1,000 feet of dry pipe out of hole in this well, you lose 30 psi. You can use this quick formula here, mud weight times 0.052 times the length of dry pipe times the steel displacement of the pipe divided by the casing capacity, deduct the dry pipe, the metal's displacement. Very simple. Next, once you pull everything out of hole, in this case you pull the drill collars out of hole. All right, the length of the drill collars of BHA here is given to you 600 feet. They give you the drill collar metal displacement, the drill collar capacity. So which figures you're going to use? Because you are tripping R4 dry, so you're going to use a metal displacement, which is 0.003 barrel per foot. Now you work out how much the bottom pressure is dropped. Similar concept. You work out the volume of the steel of drill collar that has been pulled out. You take the length times the steel displacement of drill collar. You take 600 times 0.003, you get 1.8 barrels, right? Then you work out the capacity barrel per foot of the mud left in hole between the drill collars and the casing. But now, because you have nothing in the hole, drill collars are all out. So it's just simply the casing capacity in this case, which is 0.1522 barrel per foot. So you take the volume of the steel, which is 1.8 barrel, divided by the capacity barrel per foot of 0.1522, you get 11.8 feet. So that's the height of the mud drops in the annulus. You have the height of the mud dropped, you have the mud weight, you use a constant 0.052, multiply them together, you get 6.7 psi. All of these calculations you can use with this short and quick formula here. You take the BHA length times the drill collar metal displacement divided by the casing capacity, you get the length of the mud drop in the annulus. You have that length of mud drop, you times the mud weight times 0.052, you get the bottom pressure reduction. Very simple. Now, the conclusion is when you trip R4 dry, you have all the pipe, all the steels outfall, then you lose bottom hole pressure gradually. To one point, you may start swapping it. Or even worse, you start getting underbalance and get a kick. So how to differentiate between a swap and an underbalance situation? I'll cover that in the next video. So the best practice is you check your trip sheet for correct displacement every 5 stands. And then you fill in on the backside on the annulus every 5 stands to ensure that the hole is full. All right, if you have any doubt about the displacement, you do a flow check. And if the flow shows positive, what are you going to do? So all those questions will be covered in the next video. I hope you enjoy the video and all the information is easy and straightforward for you, and see you in the next video. Cheers.